Good morning, everyone. My name is Deepika. I am an assistant professor in SNS College of Engineering. Today, I'm going to speak about the topic RSA algorithm. It is a topic which comes under the cryptography. I'll tell you in detail in the slides. Okay. First, RSA algorithm. RSA algorithm is an asymmetric algorithm. It means asymmetric means it has two types of keys. One is private key and another one is public key. As the name describes, public key is given to the public key is given public means whereas we know that public key is given to everyone and the private key is given only for the desired encryption person. Okay. For example, a client, for example, sends a public key to the server and requests for some data. If data is encrypted using an encryption algorithm, a client sends a request to process data. The server encrypts the data using client's public key. So the client has given a public key, so it encrypts through the public key and sends the encrypted data. The client receives the data and decrypts it. Only the encrypted data is sent to the client, and with his private key, he decrypts the data. Since asymmetric, nobody else is except the browser can decrypt it. The third party has a public key of a browser. If public key is only enough, but they cannot see the data. So if and only if they have a private key. The idea of RSA is based on the fact it's difficult to factorize a large integer. It means in a mathematical representation, prime numbers has a large prime numbers. We are not able to factorize it, and it is based on RSA algorithm. It is difficult to factorize it. The public key consists of two numbers, where one number is multiplication of two other two numbers. In these algorithms, basically we use only the prime keys, prime numbers. This is a block diagram of RSA algorithm, and the RSA algorithm keys can be typically 1024 or 2048 bits. Okay, but experts believe that 1024 bits keys should be broken in near further, but still it seems to be an infeasible task. Whereas in RSA algorithm, it is used 1024 and 2048, but it is like 12,200 is feasible task. So you can see here in RSA algorithm, two keys are used here. See the public key and the private key. First, the data of a plain text is encrypted using a public key. In encryption, it is used for a public key, and the conversion of ciphertext, it is used as a private key. Once the private key is encrypted, then it goes to the sender. The same way, the encryption and decryption is also given, and it is also an vice versa, private key of A and public key of A. And coming to the point, the public key is used for encryption and the private key is used for decryption. Decryption cannot be done using public key. Only decryption can be used by a private key. The two keys are linked with each other, but the private key cannot be derived from a public key. The public key is well known, but the private key is a secret. Private key is always remains a secret. It is only for the sender or the receiver. So public key is, for example, we can take a WhatsApp itself. It is a group message is a public, and when the phone password is a private key. So only if and all you use a private key to open your WhatsApp, you are able to read your data. But the public key, before you read the data, the others read it. So that is a public key. The data to be sent is encrypted by a sender using public key instead of receiver. Here it is vice versa. Like for encryption they use a private key, and for the receiver they use a decryptor. Coming to the point, B decrypts the received ciphertext using its private key, which is known only to B, and replies an encrypting its messages using A's public key. Okay. This is an encryption algorithm. See, A, it is a sender, and B, it is a receiver. Here it is a plain text. It is a mathematical representation. For the ciphertext, it is mod. M means a plain text of power E means it is an encryption mod N. This is an mathematical representation of converting the algorithm. And in the decryption, the ciphertext is decrypted and with the mod function of N. And the calculation, we have to know the values of E, D, and N. E is for encryption, D is for decryption, and N is the keys representation. Okay. So again, coming to this algorithm procedure, let us take. First we have, in our algorithm, first we have to take two numbers, two prime numbers p and q. First multiply the, first you have to get the numbers n. N is equal to p into q, whereas we have already known in Euler's theorem these three statements relatively prime, p minus 1 and q minus 1. It means that E and P minus 1 and Q minus 1 has a common factor except 1. These conditions must be satisfied in order to satisfy an RSA algorithm. This is a mathematical representation. In the further classes, we'll see about the